Okay, so we're going to talk about concentration of solutions. All year we've been using, you've been seeing on the bottles like 0.5 with a capital M or 6 with a capital M. That capital M is molarity, and that's one of our units of concentration. So now you're going to figure out how to calculate it. Concentration just simply designates the amount of solute dissolved in a given quantity or a set quantity and what do I call the thing that does the dissolving? Okay. So it's basically how much solute is in the solvent. And I would say, let's see, the greater the quantity of solute dissolved, in a set amount of solvent, the more concentrated the solution. The most common way that we measure concentration is molarity, which is just a capital M. And it is equal to the number of moles of a substance per liter of solution. And that SOLN is the abbreviation for solution. So it's moles per liter when you read that. If it's 6 molar is what I would say, that means there's 6 moles of whatever I have. Like the HCl, we often use 6 molar HCl. There's 6 moles of HCl in 1 liter of solution when I make it. If I say I have a 1 molar solution, that just means there's 1 mole in every 1 liter. It could also mean if I have a 1 molar solution, something like this. I have 0.250 mole of a substance. Let's say I have copper sulfate, copper 2 sulfate, in 0.250 liters of CuSO4 solution. Same thing. That's a 1 molar solution. So we can think about it in different ways. Where did I put the problems? So if I look at those problems that I typed up for you guys, I'm going to read the first one. I think this is where. Calculate the molarity of a solution made by dissolving 24.3 grams of sodium sulfate in enough water to form 125 milliliters of solution. So I've got some numbers there. I've got 24.3 grams and I've got 125 mLs. And what's my compound? Sodium sulfate. What's the chemical formula for sodium sulfate? Na2SO4, Kennedy says. Is she right? Yes, she is. Okay, so now I need to get this in a form. I want to know molarity, which is moles per liter, so I need to get this in a form that's usable. What do I have to do with this information right here? Change it to moles. So let's do that. I have 24.3 grams Na2SO4 and I want to get to moles. So figure out the molar mass of sodium sulfate for me real quick. I gotta find a calculator. And we'll check it. Anybody got the molar mass? Am I right? Is it 142.1? Okay. So I've got 24.3 divided by 142.1, which gives me how many moles? 0.17 moles, yeah, we good? Okay, so now I know I have 0.17 moles. I have 125 milliliters, which is how many liters? 0.125 liters. So now I have 0.17 mole in 0.125 liters. What is my molarity? Let's see. 0.17 divided by 0.125 gives me 1.36 molar. And I would write Na2SO4. Now sometimes these problems will give you, it'll ask you about the ion concentration, and that's when really we're thinking about concentration of electrolytes. So we'll talk about that real quick. This really comes into play a lot in anatomy, physiology, anything in biology, medical, when you're talking about the human body. Ion concentration within your body is super important in metabolic and cellular, I should say, processes. If your ionic concentration is out of whack, I think I talked about that before in here with lithium and how people who are paranoid schizophrenic have messed up lithium ion concentration. And it could be something as simple as your salt concentration or your potassium. If your potassium concentration is bad, it can really mess you up. People who have something called congestive heart failure, they often put them on a drug. It's called Lasix, and it's to remove that extra water that gets around the pericardial sac of their heart and in their lungs. And when they put them on the Lasix, it depletes their ion concentration, so then they piggyback it with other drugs like potassium is one. Anyhow, it's super important. It'll kill you if it gets too messed up. So if I have an ionic compound, like salt even, let's say I have 1 molar NaCl. When that dissolves, if you're asked to express the ion concentration, you would express it like this: 1 molar Na plus, because there's only one sodium, right? And 1 molar Cl minus. Ions in solution. That's how you would explain that if you were asked to discuss the ion concentration of electrolytes in a 1 molar solution of sodium chloride. Now, let me give you another one. If you were asked about a 1.0 molar solution, let's say we've just been using this, we use sodium sulfate. When I was talking, or if I were talking about that medically or in terms of in your body, I would say that I have an ion concentration of 2.0 molar Na plus, because there are two of them. Make sense? That's where I got the 2 from. And a 1.0 molar sulfate ion concentration. So when I'm expressing the concentration of an ion, an ionic substance, I can express it two ways. It can be the whole compound, the whole ionic compound, like the 1 molar sodium sulfate, or it could be by ion. So there's two different ways to express it. By ion, you have to separate it into its parts, and if it asks for the whole concentration, you just give whatever the molarity of the compound is. And if you had to calculate the molarity of the ion concentration, it would be something like we just did in that other problem. I don't know. Yeah, I don't think I put one of those on your sheet. Okay? Make sense? Oh, shoot. So that's two different ways to look at molarity. Try this. Did I type this one? I don't think I put this on your sheet. And you don't necessarily have to write the problem. I will, though. Find the concentration, I'm going to say, of each ion. In a 0.025 molar aqueous solution of calcium nitrate. Okay, try that one. That just gives you an example to try. Okay, what's my chemical formula for calcium nitrate? Yeah? Okay, and I have a 0.025 molar. So let's look at my calcium ions and let's look at my nitrate ions, because I asked you about ions. What's the molarity of my calcium concentration? What'd you get, Marin? 0.025. Yep, I didn't have to do anything. I just had to look at it. What is the molarity of my nitrate ion concentration, Jacob? 0.850. Exactly. These are so easy. You should say thank you when I give you one of these on the test. Okay? Make sense? All right, so we did all of our stoichiometry stuff. We did all of our stoichiometric equivalencies. Now we're going to use all that stuff and bring it into play with molarity and with titrations. So let's label this part interconverting. Molarity, moles, and volume is what we'll really concentrate on. If we know two of these, we can find the third. If I have something like, if I have something like my molarity equals 0.200 molar, that tells me moles and it tells me volume. And it'll allow me to calculate other quantities within a reaction if I use my stoichiometric equivalencies, or I use the reciprocal of molarity. There are lots of things that I can use here to figure stuff out. Let's say I have 2 liters of a, we'll make this, we'll use that, 0.200 molar, we'll use nitric acid again, nitric acid solution, and I say to you, contains how many moles HNO3. So I start with my quantity that I'm given, my 2 liters, and I also know my molarity. We know molarity is moles per liter, so I've got 0.2 mole per 1 liter. That allows me to cancel out liters, and it just becomes a multiplication problem to find my number of moles. So I would have 0.4 mole HNO3 within that 0.2 molar solution. I could take that a step farther, and I could have said how many grams. I would do this, I would get my 0.4, then I would find my molar mass and do the multiplication. Okay, now let's look at, it's the third one on your sheet. Calculate the volume of 0.30 molar nitric acid solution required to supply 2 mole of, oh my gosh, I can't keep that, nitric acid. So basically it's saying I'm going to use nitric acid to come up with my moles that I need. How much? I only have a 0.3 molar solution, so how much of that do I need to come up with 2 moles? So I'm going to use my 2 moles of HNO3. And here's a case, because I've got moles here, where I'm allowed to use the reciprocal of molarity. You know what I mean when I say that, right? I just flip it and put moles on the bottom and liters on the top. I just use the reciprocal. So I had a 0.3 molar solution, so that would be 0.3 mole down here and 1 liter up here. Now I've gotten rid of my moles, and I can do my math. What does that work out to be? About 6.666666. 2 divided by 0.3, is that right? Punch that in. Around 6.7 mole. So that's how much I would need of a 0.3 molar solution in order to have 6.7 moles of the nitric acid.
Would it be liters?
What did I write?
Moles?
Yeah, it would be liters, sorry. I'm saying one thing, writing another thing. Thank you. So it should be 6.7 liters. So in that 6.7 liters, there are 2 moles of nitric acid. How many grams of nitric acid are in there? Figure it out. Don't let it mess you up, or don't let me mess you up. Use the information you need to figure out how many grams are in there. When you have an answer, stand up. Okay, who thinks they have the right answer? What'd you do, Jacob? Tell us what you did.
The 2 moles. I turned moles to grams, so I did 2 times 63 grams because that's how many
Okay.
grams you.
Is that what the rest of you did? Anybody use 0.3? No, because that was the moles in my original quantity. So good job if that's what you did. Okay, one other way to look at it. I'm almost done. If one of the solutes is a liquid, which often happens when we make these solutions, then density can be used to find mass or volume as needed. So it can go either way. Then I put a lovely example problem on there. If you look at the fourth one, American beer contains 5% ethanol, and then I gave you the formula for ethanol by volume in water. So most of beer is water. 5% of it is actually alcohol. We call it alcohol. The real name for the alcohol in beer is ethanol. The density of that is 0.789 grams per milliliter. Calculate the molarity of ethanol in 1 liter of beer. So I'm going to think about 1 liter of beer. And this is actually the best application that allows you to see it. So if I have 1 liter of beer and I know that 5% of it is ethanol, I can say that I have 0.950 liters of beer and 0.05 liters of ethanol. Make sense? So then the next thing that I want to do is I'm going to go ahead and have you find the molar mass of ethanol. You've got the formula on your paper. Find its molar mass real quick because we're going to need it. Are you hungry, Kennedy? What's the molar mass? You got it, Lucas? 46. You guys agree with him? Yeah, that's right. Okay, so I've got, and I want to know about the ethanol. calculate the molarity of ethanol. Did I write that on your paper? Yeah, okay. So, I'm going to find the molarity. I know I have 0.050 liters, and I'm going to have to use that density that I was given. So I need to use 1,000 milliliters in 1 liter because my density is, what was it? 0.789 grams per milliliter. So I have to get that taken care of. And I have 0.789 grams, so I use 1 mole has 46 grams. Now look at what you just wrote down and make sure all the numbers make sense, because I kind of did it in one long problem. So I've gotten rid of liters, I've gotten rid of milliliters by using my density, I've gotten rid of grams by using my density, and I'm to moles, which is, I believe that's what I asked you for. Calculate the molarity, or in moles per, okay. So, how many moles do I have for every liter? Get an answer. Did anybody punch it in yet? What you got, Jacob? 0.86 mole per 1 liter. This would be mole ethanol per 1 liter of solution, which in this case my solution is my beer and water, or my alcohol and water. So anytime, oh yeah, I'm sorry, Maren. Anytime I have a solution that it's a pure substance or it's a mixture, and I know the density of this one of the solutes in it, in this case the ethanol is actually dissolved in the water or dispersed in the water. It's not dissociated because it's a molecular compound, but it's dissolved. I can use its density to figure out what I've got going on. I just have to use it in the right way. Okay, here's one. Let's try the let's try one more. I don't think I have an example of this kind on your paper. I have to put this one in your notes. Try this. It's another way to look at it. How many grams sodium sulfate are required to make 0.350 liter of a 0.5 molar solution. Now look at that for a minute and see if you can figure out where to start. I need 0.350 liters of what? A 0.5 molar solution. How many grams do I need? Well, let's see. If I do that math, that gets me to how many grams? Well, it gets me to moles. What is that? 0.350 times 0.5 is 0.175 mole. Yes? Now I can take 0.175 mole Na2SO4, and every 1 mole, I forget what our molar mass was, we figured that out before. 23 times 2 plus 142.1. Close. So I have 24.9 grams of Na2 SO4 are needed. Make sense? Questions? So this is all about concentration. Normally what we use in here in lab, like I have a cabinet back there that has a padlock on it. It's full of super strong acids. I have nitric acid, sulfuric acid, hydrochloric acid. All of those things are back there. When I purchase them in extremely concentrated quantities. Like I'll have a gallon jug of HCl that's greater than 12 molar. So when we want to use it in lab, if I only want a 1 molar solution, I have to calculate how much of that concentrated HCl I need to use to make that 1 molar solution, or whatever the lab happens to call for. So when you do something like that, it's called dilution, or the process of dilution. So that's the last thing I'm going to show you today. And this is taking a concentrated solution and lowering the concentration. The important thing to remember here is the moles of solute before dilution equals the moles of solute after. I'm going to let you write that and then we'll talk about it for just a second. So if I have 12 molar HCl and I have a liter of it, think about that, 12 molar HCl, and I have a whole liter of it, then I have 12 moles in 1 liter. Just because, let's say I want to dilute that, and I want to make it 3 liters, it doesn't change the number of moles I have in it. It changes the molarity, but now I would have 12 mole in 3 liters. So now I only have a 4 molar concentration, right? So at no point do the number of moles present change. If I don't want to give you guys a whole liter of it, I just give you 250 milliliters or whatever. So it's not like you're changing the quantity of moles that are there. You're changing the quantity of solvent that's present. And the way that we figure these things out, this is really easy mathematically. You take the moles, or the molarity of the concentrated solution, times the volume of the concentrated solution, and set it equal to the molarity of the dilute solution times the volume of the dilute solution. And you can find any one of those 4 things really easy. It becomes a nice linear equation. Yes. Yes, I will. The moles of concentrated times the volume of concentrated is equal to the molarity of the dilute solution times the volume of the dilute solution. So molarity and volume in each case. So look at the 5th one down on your paper. How many milliliters of 3 molar sulfuric acid are needed to make 450 milliliters of a 0.1 molar solution of sulfuric acid? So what's my concentrated molarity? Or what's my only molarity? To be honest with you, you don't even have to worry about concentrated and dilute, which one comes first. Just keep your concentrated molarity and volume together in your dilute. It doesn't matter what order you put them in. So I have how many milliliters of 3 are needed to make, so my strong solution is a 3 molar, right? So I'm going to start with that. 3.0 molar. How many milliliters? So this is what I don't know. Volume of my concentrated are needed to make 450 milliliters of a 0.1 molar solution. Now I can easily solve for the volume of the concentrated solution that I need. That'd be in a- Is that right? Yeah? Okay. So I would say 15 milliliters of what are needed? A 3.0 molar solution of, what was I working with here? Sulfuric acid, H2SO4, are needed if I were giving an answer. That's the way I would write it. I sure will. Okay, I'm going to work through the last one on the paper. This is one where we really have to use our stoichiometric equivalencies. This is one of the more difficult ones. These are easy ones too, just like ion concentration. So the very last one I'm going to show you puts a whole bunch of things together. So if we read the one on the bottom of the page, how many grams of calcium hydroxide are needed to neutralize 25 milliliters of 0.1 molar nitric acid? So I have some things that I know. The first thing, when you're given one of these that there are not a lot of clues in, the best thing to do is to start by writing the balanced chemical equation. So see if you can write the balanced chemical equation for what's going on in that last question. You have your two reactants, you just have to figure out your products. Don't forget to balance it. Cole, do you have an equation?
Yes.
Okay, you want to tell me what it is?
CaOH2 plus 2H3 equals 2H2O plus CaNO3 2.
Tell me the other side of your equation.
2H2O plus CaNO3 2.
Yeah, that looks good. Whoops, I forgot my 2 right there. Hey, is this aqueous or solid? Aqueous. How did you know that so fast? Nitrate, yep. Okay, and obviously I'm going to start over here on this side with aqueous and aqueous. Okay, so now, that is a good balanced equation. Let's go back to my problem, and what do I know? I have 25 milliliters of, oh, write your stoichiometric equivalency real quick. And then we'll be ready to start. Okay, so I have 25 milliliters of what? A 0.1 molar solution, 0.1 mole or 1 liter. So that allows me to figure out how many, and what do I have here? This is CaOH. Alright, so I should have made this 1,000 milliliters because I've got milliliters up there. So I'm going to get those to cancel out, which gives me how many moles? 0.0025 mole of CaOH twice. So I've used my molarity to get to moles. Now what can I do next? Was that not right? Oh, I forgot. 0.25. Yeah, this is nitric acid. Okay, so, anyhow, I wrote the wrong compound down. I did. That's how many moles I have of, I should change it over here. Thank you, whoever said that. I think that must be what you were thinking. I saw your face. Like,
No, I'm just confused.
what are you confused about?
So I thought we'd be multiplying like 25 times point. Oh, wait. I don't know what's going on. It's fine. I'll figure it out.
Okay. I don't like that, Drake. Okay, so are we good now? Yeah? I took the quantity that I had
Yeah.
times the molarity.
Yep.
Except for I changed my liters to milliliters so these things would cancel out. Okay? I got the number of moles I have of nitric acid. So I'm going to carry those down, my moles of nitric acid. And I'm going to use some stoichiometric equivalencies. What do I really want to know about? Calcium hydroxide. So I have to use my stoichiometric equivalency between nitric acid and calcium hydroxide. So for every 2 HNO3, I have 1 CaOH twice. So that gives me how many moles of calcium hydroxide? Punch that in and see. .00125 mole of calcium hydroxide. Is that right? Okay. So now I know how many moles of calcium hydroxide I have. What do I really want to know in the end? What's the problem asking you for? Grams. So I have to convert my moles, my .00125 mole CaOH twice to grams. So you have to figure out the molar mass of calcium hydroxide. I can't remember calcium. So I don't need very much, do I? Is that right? Yeah. My messy writing. Is that math right? Okay. So that's the one that makes you think all the way through the process. What's wrong, Lucas? What can't you read?
I just didn't know if it was a 2 or a 3.
That's a 3. It started as a 2, but then I'm like, no, it should be a 3. I need a round, so I just made a big ugly 3. See, it's good when I challenge you to read my writing, because you challenge me all the time. Okay, so I'm stopping there. Here's what I'm going to do. Tomorrow, I'll just leave you some problems like these to work. And I'm going to leave you an activity series handout, just because I think it'll be good for you. Spend 10 minutes in study hall memorizing the activity series. Make yourself do it. Otherwise, Monday will be painful. Oh, thanks.
This was the packet we need to turn in for the lab.
Did you give me your, you didn't hear the, yeah, I need that. So
Just that.
I'll just take that.
Okay, thank you.
You guys, does anybody else have one of these for me that, I know some of you submitted yesterday. I've got some of them, but not all of them. Eventually, I need that tomorrow at the latest. That's when lab reports are due.
I'll show her. Yeah.
Do organic chemistry too this year.
Depends on what.
I know.
You realize the 2 charts are gonna be confused. That's, dude, I used to. Now, well, I don't know. It would be late at night. Then they put perfumes. And then it's oh, I haven't.
I hope you didn't say anything bad while I was gone.